はい、ありがとうございます。
Thank you. Thank you for the introduction. I'm from QStar, and Quantum Strategic Industry Alliance for Revolution is the name. And I'm a chair of executive committee. My name is Okada. As Mr. Tanaka said, we want to commercialize the quantum technology and wanted to pay tax as soon as possible. That is the nature of our organization. And I have another cap. Well, I'm a corporate senior vice president of Toshiba Corporation. First of all, those of you who are here with us, I don't think I need to talk about this, but quantum computer relevant evolution for the past year seems to be accelerated further. So that's the first thing I'd like to talk about. So within the Q2B session that we have, I have some conversation with some of the participants. Last year, we were focusing on the physical qubit, but this year, logical qubit is the focus of our attention. So I think this is one of the major change compared to the last year's Q2B. So the physical qubit development is going smooth. That's what I see is happening. And so logical qubit and evolution. Well, last year, QERA made a major announcement. Error correction algorithm evolution is being highlighted, and there's a great stride made in that area. So, as Mr. Tanaka mentioned earlier in his presentation, NISC 2 FTQC. So, there is a lot of expectation coming from the industry players. So, QStar, I'm going to come back to this later. But using the quantum technology, what kind of industry we can establish and how we can use it. That's the topic we discuss. That's until last year, we were talking about what we can do using NISC. We were seriously talking about that. Of course, there is a lot of limitation when it comes to using NISC, but starting from this year, we don't have to think about the use case, just focusing on the NISC. We can assume that we can attain FTQC. So we saw evolution enough for us to move that far. On the other hand, and so what is the situation here in Japan? So this slide shows that. Last year, in March, for the first time in Japan, and the quantum gate machine was born at Riken. Of course, it was made by the Riken Center, but many Japanese companies are being part of this to make it successful, as Mr. Tanaka mentioned. So this outcome help Fujitsu to commercialize this. Fujitsu is also a member of the QStart, and that will be delivered to GQuad next year. Furthermore, University of Tokyo, using photon algorithm, they made a qubit and cold atom, and a project of Professor Omori of QST. And so there's a project going on with this assumption as being successful. So basic quantum technology development here in Japan saw a large advancement. That's what happened last year. Another point I'd like to highlight about this year, this Alice and Bob company's announcement, Cat Qubit. And the coherent of the qubit is quite long. And so this can create that long coherence time. This year, May this year, I'm going to come back to this. And so QWIC, that is a European counterpart of a QSTARS, I participated in a plenary meeting. And that was after this major announcement. So this was a big topic discussed at that forum. And so evolution of the quantum technology is quite evident. So looking at the different countries, they are also actively supporting these initiatives. As Mr. Tanaka mentioned earlier, towards next generation development as a frontier technology, and also as a way to increase the country's national power. And it is serving, quantum technology is serving as a pillar. When you talk about the quantum technology, I want you to imagine 1985 or 1990, to think about what was the situation like for the internet. So the spread of the internet back then, as no one can assume. But now we cannot live without the internet. And to use smartphone to enjoy videos and movies. And so the quantum technologies is similar to that situation. And 100 trillion and 200 trillion, a size of industry is expected to be built, and that is for sure. So how we can make an investment and how we're going to crystallize that is the challenges that we are facing. Of course, a private sector needs to make investment, but also in order to make a new industry, we need to have a strong support coming from different countries. And so sharing this passion among different countries, and I'm sure that they're also making a great investment. So today, Q2B is Aurora, which is quite open quantum to business. So what I'd like to talk today is one country cannot achieve anything in this field. Of course, different countries have a different level of a budget, but there's no country talking about they want to build an ecosystem within their own countries. So on a wider area, what we need to do is to establish a global ecosystem. And so Q-Star is also focusing on that theme. And so one of the milestone is coming next year. UNESCO defined quantum science and technology year. So it is to be next year is the International Year of Quantum Science and Technology. UNESCO declared that. And so all the affiliated organization or the other company are going to come up with the innovative ideas to make buzz. So I hope you will be also be part of it. And also another exciting thing happening next year is Expo 2025 to be held here in Japan. And so this Expo 2025 in Osaka, they're talking about they're going to exhibit quantum technologies as well. We cannot make any announcement yet, but quantum is going to be closer to you. And next year, you'll feel closer to quantum technology. And that's how we want to make next year to be, to celebrate this year. Q-Star was founded in 2021. And so original 11 member discuss what needs to be happen. And so a number of membership grew to 97 from 24. And as Mr. Tanaka said, so quantum technology that the Japanese government being announced, there are 4 documents. And so Q-Star also made a recommendation relevant to those 4 major documents released by the Japanese government. And maybe this is the term that you're familiar to the Japanese people, 2030. So making 10 million quantum technology users in Japan. And to create the word of such, that is the sentence that the Q-Star recommended for the Japanese government to use. 10 million people is a significant number. I talked about the internet, so prevalence of the internet. 5 to 10%, well, the popularization of the internet to the total population, I saw a great jump. So 10 million is the 5 to 10 million, 10% of the general population. That is why we have as a target. So also quantum technology has to be common to everyone because quantum technology cannot be used standalone, I believe so. So it has to be combined with existing technologies. So if you search something using the smartphone, and then what's running behind is a quantum technology to speed up to find what you're searching for. So how quantum technology can be combined with existing technology is key to commercialization. So 2030, achieving 10 million quantum technology users in Japan is where that come from. And so 97 members, the participants to the Q-Stars, and most of them are end users. And this is quite unique compared to other organizations in different parts of the world. And so the Japanese industry do pay high attention to how they can utilize quantum technologies. And also we see industry participants here with us. So 97 members. So three more and we can make it 100 members. So I hope there will be three more volunteers today so that we can achieve 100 membership for the Q Star. So please remember, we want to grow the membership further. So activities of the Q Star, on our hand side, subcommittee activities are the main activities. In each areas, what kind of use cases that they can make being discussed. So starting from at the very beginning, they have been very active. So G-Quad, and they're going to have actual machine to be delivered. So they are going to be full-fledged in taking activities. So G-Quad, I hope is also be contributable to enhance our subcommittee activities. And at the very bottom, there is a new subcommittee. This is about SDGs. And you can feel the heat today, and you can see how a climate challenge is also can be addressed by using quantum technology. And one another thing I'd like to talk about the QStar activity is this: two different types. When it comes to quantum computers, you have to make a quantum state. You have to make a qubit and then address the problems. That is the nature of the problem-solving approach. But the algorithm or the quantum world, well, there's a technology to assimilate using the existing computer is evolving, especially annealing type simulation is quite popular here in Japan. In a pure sense, and it's not using a quantum state, but conducting simulation in such a way could be considered as a one big category. That's why we have this. So what come out of simulator, and if that is used to address the problem, and it can be used even if the machine is replaced with the quantum computers. Whether that is a computer is using quantum or not, from the industry players' point of view, it doesn't matter. As long as the actual product's been addressed, that is fine. So using the nature of the quantum or the potential of quantum, using it as soon as possible, and using simulated quantum inspired machine, if that can help to address problem, that will be wonderful as well. This simulated computer, using this, there are many use cases arising. Fujitsu, Hitachi, NEC, Toshiba. These are the things I picked up from their homepages. So here in Japan, these been used, put in use already. So logistic, manufacturing, finance, in these areas, this has been already utilized. And also, what is the Japanese strength in a global arena? It's a QKD and quantum key delivery. So once we have a quantum computer, and so cryptography is going to be deciphered quickly. So we need to protect quickly. So there is a threat of harvesting data now and then decrypting later. So we need to prepare for that. So a quantum technology which can be decrypted is something that being gathering attention in the different parts of the world. Here, QKD, global activities, and some of the examples are shown here. In London, BT, with them, within the London areas, outside of the city, and linking those days and protecting the financial information by having secure line. In USA, demonstration project is going on, and Singapore, Spectrum, those are leading player of satellites and quantum cryptography area. We do have a tie-up with them. In Tokyo, and Tokyo Metro Network is in place and connecting 12 points and using QKD. And so financial institutions are conducting this demonstration project. In the middle, you see the SoftBank examples. So below this existing VPN, we have a quantum secure lines, and this is also the demonstration project which is ongoing. So there has been a lot of demonstration projects going on in the different countries. So because we have a Q2B, I'd like to share the highlight. So this technology of QKG, well, it's not that only the pure QKD is going to be PQC needs to be combined to make a more secure environment on both sides. So starting from last year to this year, I think this is also the major trend like that is coming in. And PQC or QKD, well, there's always talk about which one is it, but this year we need to compensate the weakness, and then we should compensate each other to make it more secure. And I think that has been tested in the test bed in each country, and also here in Japan, that is ongoing. And so, a quantum-inspired machine, as mentioned earlier, there is also exhibition today. Toshiba SQBM Plus inspired engine is used, and financial and drug discovery, manufacturing. There's many use cases being built. Furthermore, SQBM Plus, well, this is already available on Azure or AWS. And so Pixar's Amplify, Japanese leader company in the quantum area, is also ready. And also the StrangeWorks network, this is also ready. So you can use algorithm utilizing those platforms. If you're with Toshiba, and so you tend to encounter case studies which are used by the countries you don't know. So, what are the use cases utilizing quantum-inspired technology or engines, and disseminating that information from Japan will be to stimulate the industry development. Drug discovery is one, and also Topan's use case was also announced the other day. Earlier, G-Quad was mentioned. Well, as industry players, we wanted to establish an environment to solve the problem. And so being able to use a test bed like this, though it's a Japanese government initiative, is wonderful. Well, because it is impossible for each company to buy quantum computers. And of course, they can use cloud. And that's also important. But utilizing on the actual machine is also the key. And hybrid environment is what they have. So existing computer and quantum computer combined. So this could serve as the contributable factor for the exit strategies. And so there has been a joint symposium between Q-Star and G-Quad. And it was a very exciting conference held last month. And so G-Quad and Q-Star, we discussed all these things, not just quantum, but combination hybrid with the classic systems, and how to address problems and how to use quantum is what we discussed, and also spiral up. And so evolution of the technology and catching up with this spiral is also one of the major targets. And so software is a key here. At the bottom, you see different approach you-based quantum computers are shown. Well, I don't know whether I should say this or not. So which computer is going to be the main or the winner or not? We don't know which approach this kind of computer is going to take, but each approach have different characteristics. So if you want to address actual problems, and there has to be an absorbent layer to absorb all this. So within our organization, we are talking about this importance of the middle layer. And so what we have announced on the 11th is a software stack design. So quantum computer, it's just been built as a machine. So it's not like a digital computer. It's not like there are solid utility standardized or language standardized or the operation system being standardized. It's not get to that level yet. So different approach computers. And in order to get to the area where that we can address actual problems, that is the application, and what kind of a middleware we need, and what we can commonize or standardize. That's something that we discuss at Q-Star. We have discussed globally. Of course, it's difficult to define as one, so we can thinking about the having the selections and define the usage. And so we are determined to talk with the neighboring countries, QEDC, Quake of Europe, and QAC of Canada, and QSTAR. So of ICQIA, the consortium was built among those four associations. It was established in January last year, and we have a very fruitful discussion. For instance, supply chain, and sensing and communication, and what kind of materials is needed. And so each country has a different technology, and we share those technological information and then have a deeper discussion. So that's what we're doing. This is the QWIC plenary meeting taking place in the Netherlands that I mentioned earlier. As I said earlier, and we wanted to build a new industry. So quantum technology and should be used widely in each segment of industry. And we see what, much more than what we have expected today, and we want to do so together with the global peers. So thank you for your precious time.